Okay, hello everyone. My name is Animesh Gupta, and today I'm going to give a demonstration of a smart human activity detection system that we have designed using YOLO, which is also called, which is the full form of You Only Look Once algorithm. It's an open source algorithm. So we have had to make four very specific applications for this particular project, and they are object detection, vehicle crash detection, fall detection, and social distancing detection. But the primary question is, why do we need to have these very specific four applications? And the biggest reason is COVID-19. So during these torrid times, we've had a very bad luck of having a very bad disease plaguing our world, and the government has implemented certain guidelines of social distancing. So it's very important to maintain social distancing in schools and colleges alike. And our project, it does what it recognizes that in a crowded area, if there are a lot of people, it generates an error message that a lot of people are standing in that very particular place, which can be dangerous also. So for the purpose of this demonstration, let's start with the vehicle crash detection. So what for vehicle crash detection, what I do is that let me show you the code for the whole program. And as you can see, this is the code which has been designed in a very specific manner. Now let me show you the website. Okay, so I'm going, for the purpose of the demonstration of this project, our whole system has been designed on a local machine, because in real world this would have been hosted on an AWS server, but that would cost money. So for this particular demonstration, we are going to host it on this machine. So let me run this code. And the website has been hosted, and as you can see, this is the front page. So the biggest factor also is that this is a single unified page. So it makes the work of any person who's monitoring the system very easy, because all of these applications can be accessed through one single page. And I think that is the most important aspect of this project. So let's type an object detection link right here, video. So this is a YouTube video, and as we can see, right there, this is the demonstration of the video. You can see boxes that have been covered around people, and also the bus, and also the handbag that has been detected over there. And the text is written on the top of the box, and also a confidence score right beside that, which shows what is the percentage of the certainty that that object has been recognized. Second is the vehicle crash detection. So I'll use this link for the purpose of this demonstration. And as you can see, when you can see the cars going around the screen, and they are colored in green because there has been no crash. And as soon as a crash occurs, a red color bar is displayed around that particular area, and an error is generated on the top of the screen. And the third is fall detection. Again, I'll type in this YouTube link video. And yes, you can see this demonstration. And as soon as a person falls, the fall has been detected. We have done this by writing a very simple line of logic, which is that initially when the person is standing, the height of the rectangle will be greater than the breadth of the rectangle, and as soon as the person falls, the height dramatically reduces. And if the height stays constant, or in other words, if the person has fallen, then an error message with a red colored box is generated automatically. And now finally, the social distancing detection. I'll type in the code. And yeah, you can see the video. So you can see people, they have been highlighted in green color, and as soon and it shows that the people at risk mark right across the screen, and as soon as it recognizes that there are more people in a very less distance, it shows that number right across the screen. So that can be really beneficial for students to maintain their social distancing guidelines. Now this was a demonstration which had links from YouTube or any other online means of storage. Now what I'll do is that I'll run this code on this very machine, and I'll use videos which are stored on this particular device. So as you can see, it runs much more smoothly because this is being run locally on this device, and behind the screen you can see the frame rate that is shown, and it is about 45 to 40 frames per second, which is a very good frame rate for running this particular algorithm, and it runs extremely smoothly. Also you can see you can use multiple sources for the purpose of the demonstration. So you can have a video stored on the local machine, or you can use any video on the online medium, or you can also use a real-time based application. So you can capture the video like in any CCTV footage, and you can use that footage and then run the algorithm on that footage in real time, and that's one of the biggest working of this algorithm. So for the purpose of this demonstration, I'll use an application called DroidCam. What it does is that it fetches the video which is being captured by a live mobile phone, and it passes that video to a server that has been hosted locally. And you can see this is the live real footage of my friend who falls, and as you can see, as soon as he falls, a red color mark has been generated. So it runs extremely smoothly, again a frame rate of around 50 to 55 frames per second, which is I think very good for this particular scenario. And now I'll show you my own video. So this is a stored video, and as you can see, this is the original video, and after this I'll run the algorithm on this particular video. And yes, you can see that the person falls, or in my case I fall, and it shows that red color bar. Also, apart from all of this, the most important aspect is informing the emergency contacts, or informing the senior authorities who will be responsible for taking an action in such a scenario. So let us suppose that the students are playing in the grounds, or they are standing in a morning assembly, and one of them trips and falls during playing, or due to a lot of heat they fall down during their assembly. So there has to be a system that is capable of recognizing this and then generating an important push notification or any sort of message that can be sent wirelessly to any emergency contact, any teacher, or any staff in the school premise that can take the necessary action. So for that I'll show you the demonstration. Yes, and you can see as soon as my own video detects that a fall has been generated, so I'll go to the receiver's end of Gmail account, and yes, you can see that a mail has been generated right here, and it shows the screenshots of the person that has fallen, and it also shows that a very important emergency message that might be necessary in that particular situation. So I think all these aspects are really important for a project of this caliber. And yeah, all of these pages have been all of this interface has been hosted on GitHub pages right here. And all of the code, all of the description and how to use this particular algorithm is described on the GitHub resource, which has been listed below. The setup time is about 4 hours, and it shows how YOLO works, the algorithm underlying this whole application. And yeah, I think that is it. So thank you very much.